In section 8.6, we're now going to move on to working with quadratic functions that have a leading coefficient that's something other than 1. So this becomes a little more complicated. We're still working with trinomials essentially. And what we want to do is we want to go ahead and now account for that leading coefficient. We didn't really have to account for it before when it was 1 because it was just too easy. So when b is negative and c is positive, so I know that my signs are the same. I know that they're both subtraction, right? So that part hasn't changed. I still know I'm going to have a c and a c, but I have to now work with the factors of 10 and the factors of 4. So factors of 10 are 1 and 10 and 2 and 5. And then my factors of 4 are 1 and 4 or 2 and 2. Okay, and what we want to look at is how do these outsides and insides happen? How could they happen? So if I have 1 times 10 and I have 4 times 1, those will add up to be 14. So I need to make sure that I put, remember these are my leading coefficients. So if I put a square here, I have to put a square here. So those things will be multiplied together. So I can put a 10 here, and that means the 1 goes here. And the other leading coefficient factor was 1. If that goes here, so now I'm putting a circle here, I'm going to put a circle there. So the 1 goes here, and that means that the 4 goes there. And if I want to double check my work, 10c times 1c is 10c squared. 10c times negative 1 is minus 10c. Negative 4 times 1 is minus 4c. Right? Negative 4 times 1c. And negative 4 times negative 1 is plus 4. And when I combine like terms, I'll have 10c squared minus 14c plus 4. Okay? Now, this is kind of a unique problem because I could have done it another way. I could have had 2 times 5 is 10, and 2 times 2 is 4. So it would have been equally valid to factor it that way. Okay, and I do want to talk a little bit about that as we continue on. So if I take my c here, and I take my c there, minus, I'm going to put, again, these guys here have to go with the leading coefficient. So I can put a 5 here, and then the 2 is there. So the 5 was the square, and the 2 is the circle. So if the square went here, the square goes here, right? And this circle will go here. Okay, so if we take a look at that, we go, well, why can I factor it both ways? Well, part of it is because I didn't do what I typically tell you is the most important thing to do when you first begin, and that's look to see if there's something you can factor out of all the different parts, and there is. I could factor the 2 out of this. If I factor the 2 out of it, then I'm going to get 5c squared minus 7c plus 2. All right, if I go ahead and factor this, now I've got the factors of 5 and the factors of 2, right? So I've got 1 and 5, 1 and 2, and they've got to combine to be 7, so 5 times 1 and 2 times 1, right? It's a lot easier to factor when these are down to be prime numbers. I know that my signs are still the same, and they're both minuses. I know that. So if I put 5c here, then I put 1c there. And then the 5 had to get multiplied times the 1, and the 1 has to get multiplied times the 2, and this is what I get. Now, if we talk about solutions, you notice the solutions here, if I set this to be equal to 0, I'll add 2 and divide by 5, so that would be 2/5. And here I'll just add 1, so that would be 1. if I find the solutions from this, I'm going to add 2 and divide by 5. That's 2/5. And I'm going to add 2 and divide by 2. That's going to be 1. Oh, wait, those are the same numbers. And if I look at these, if I add 4 and divide by 10, that's going to be 4/10, but that's 2/5. And I'm going to add 1 and divide by that, and that's 1. So you'll notice that the solutions on all 3 different ways I have done this are the same. Okay, so it isn't necessarily that you have to find the easiest way to do things in order to be right, but you want to stay open to the fact that you've got to keep working through the problem until you get to the ends of the solutions. Okay, let's look at another problem. Okay, so I have a minus sign here, and that means to me that this is a plus and that's a minus. I still know s times s is going to make s squared. And now I need the factors of 4, which are 1 and 4, or 2 and 2. And I've got the factors of 3, which are 1 and 3. And I want to have products that have a difference of 11. So it's always, the products do this to make that number. So it's a difference of 11. Well, if I do 3 times 12, or 3 times 4, that's 12. And 1 times 1, that's going to be 1. And 12 and 1 have a difference of 11. Now this is where it gets a little tricky, is that it has to come out positive, which means that the bigger product, that's 4 times 3, has to become positive, which means that the 3 has to go with the positive sign. And that puts the 4 over here. That means that's a 1 and that's a 1. If we check our work, we'll have 4s squared minus 1s plus 12s, minus 1 plus 12 is plus 11, and then 3 times negative 1 is negative 3. So that does check out. If we wanted to find our solutions, I'll have s plus 3 equal to 0. So s is equal to negative 3. And I'll have 4s minus 1 equal to 0. And that will become s is equal to 1/4. Solutions. Okay, another example here. What do I do when I've got a leading coefficient that's negative? The first thing I'm going to do is I'm going to factor a negative 1 out of everything. Right? So I'll have negative 1 times a squared minus 12a plus 27. Now this last sign is a plus. That means the signs are the same. And they're both going to be minuses. So I know I got minus and minus. I have a squared and a squared. And I want factors of 27 that will add up to be 12. Well, that's 3 and 9. So I've totally factored this. This is an A, not a 9. Right? A. Okay, another way you could look at this whole factoring a negative 1 out of everything is you could say, well, I'm going to move everything to the other side. And if I do that, then I know I'll have nothing over here, and I will add 16k squared. I will subtract 8k. And I will subtract 24. And you see now I have a positive leading coefficient, and I didn't really factor the negative 1 out. Instead, I just added or subtracted to get everything onto the other side. Now when I look at these terms, each of these is divisible by 8. So I'm going to factor an 8 out of this. And 8 out of 16k squared is 2k squared. And 8 out of negative 8k is negative k. And 8 out of negative 24 is negative 3. And now when I want to factor this, I know that my signs are going to be different. One's going to be a plus and one's going to be a minus. And I know that the bigger product has to come out negative. And I've got the factors of 2, which are 1 and 2, and the factors of 3, which are 1 and 3. And we have to have a difference of 1. So I'm going to do 3 times 1 and 2 times 1. Remembering that the 3 has to go here, right? So that I'll get negative 3k. So this was k. And over here I have 2k and 1. So I placed my factors of the leading coefficient, 1 and 2, and factors of the constant, 1 and 3, in the correct places. Okay, if I want to go ahead and solve this, the 8 is not involved. K can be -1, or if I add 3 and divide by 2, 3/2. Okay, those are my solutions. Okay, one last example here. We've got an athlete who's going to throw a discus, and we're going to be using our, we learned earlier an equation for the height of an item in motion. I know that height is equal to -16t squared plus velocity, initial velocity times t plus initial height. Right? So this is velocity at time 0 and height at time 0. So if I want to write the equation, I know that it's an initial height of 6 feet. So let's see, my height is going to be equal to -16t squared. My initial height is 6 feet, so I'm putting that at the end. An initial vertical velocity of 46 feet per second, so that's going to be plus 46t. Okay, after how many seconds does the discus hit the ground? Well, it's going to be, it hits the ground when it's at height 0. So I'm setting the height to be 0, -16t squared plus 46t plus 6. And you can see that I could factor a 2 out of everything. So I'll factor out a 2. In fact, I'm going to factor out a -2 because I want a positive leading coefficient. So then this is going to be 8t squared, and this is going to be minus 23t, and this is going to be minus 3. Okay, now when I want to go ahead and factor this, I know that I'm going to be working with factors of 8, 1 and 8, or 2 and 4, and the factors of 3, 1 and 3. And I know in my binomials the signs are going to be different. Right? I know there's going to be a t plus, and I know I'm going to have a t minus. And I know that my products have to come out to be negative, so I know that the bigger product has to have the factor of the constant be there. And then I want a difference of 23. Well, 3 times 8 is 24, and 1 times 1 is 1, so they have a difference of 23. 8 times 3 is the bigger product, so the 3 has to go with the minus, and that means the 8 goes over here, right? So these are my squares, and that means these are my circles. And so the circle 1 goes there, and the other one goes there. So now when we talk about after how many seconds does the discus hit the ground, if I solve this binomial, remember this is going to be equal to 0, the -2 has nothing to do with anything. So if I set this to be equal to 0, 8t plus 1 equal to 0, I'll subtract 1 and divide by 8. So t will be equal to -1/8. And then over here, I'll add 3 and divide by 1, so t will be equal to 3. Okay, so I have 2 answers. How do I know which is the situation? And they're both correct. They're both when the discus hits 0. But remember, at time 0, we started at 6 feet. Right here are 2 zeros. At time 0, we were right here at 6 feet. So the -1/8 is how far back in the past would I had to go to fling the discus from the ground. I flung it from the height of the person, so it's 6 feet. So the positive number is going to be our solution. 3 seconds in the future, that's when the discus is going to hit the ground, not 1/8 of a second in the past. Okay, so that's important for you to think about when you're interpreting the results. You may find two solutions, but only one of them actually answers the question you're looking for.